Hi, my name is Mariah Kidd. Today I'm going to be talking about DNA replication in prokaryotes. So our origin of replication is where our process is going to start, and because it's a prokaryote, it's only going to have one place of origin. Helicase, the unzipping enzyme, is going to come in and start to unzip our double helix. It does this by breaking the hydrogen bond in between the bases. It's now going to come to the replication fork and continue to unwind the DNA until the whole strand has been replicated. Next, single binding proteins are going to come in and bind to the DNA strand. This will keep the double helix from reforming, and it does this by making sure hydrogen bonds don't reform. Gyrase is then going to come in and make sure supercoiling does not occur. Supercoiling will happen as helicase continues to unwind the DNA and makes it get overwound. It's going to keep supercoiling from happening by breaking and reforming phosphodiester bonds so that the DNA remains in its relaxed state. Primase is then going to come in and form primers. Without primase, DNA polymerase III would not know where to start the replication process. DNA polymerase III can only move in the 5' to 3' direction. And because of this, it's going to have to come back when it finishes and then constantly go in this direction. This creates these little fragments. These are called Okazaki fragments. Because DNA polymerase III has to always wait for a new primer to be placed as the replication fork opens, it will always be a little bit behind. Therefore, it is called the lagging strand. And the one that goes in one continuous motion is called the leading strand. Next, DNA polymerase I is going to come in and replace our RNA primers left by primase and replace them with DNA fragments. After this, ligase, which I like to call our gluing enzyme, is going to come in and fill in the nicks in between the fragments. It does this by creating a sugar phosphate bond. At the end of our process, we're going to be left with two new DNA strands, each containing 50% of the parent DNA and 50% of the new strand that was replicated.